we will carry out the refrigeration performance analysis experiment according to the evaporation load change. Monitoring the refrigeration performance by varying the load through various manipulation of the experimental equipment. Students draw a pH diagram with the measured values directly. So, analyze the performance of the system using the plotted diagram. At once, in order to experiment, we check various factors to give two changes in the evaporation load. First, check the ambient temperature. The current outside temperature is 25.1 degrees Celsius. Second, when analyzing refrigeration performance according to evaporation load change, the condenser fan motor operates at maximum RPM and opens both the front and rear dampers of the evaporation chamber. Third, the amount of refrigerant circulation is adjusted by varying the opening degree of the expansion valve. Adjust the evaporator fan motor RPM to adjust the evaporation load, and adjust the damper of the evaporator chamber. Next, let's explain how to operate the evaporator acrylic chamber. Open the front and rear dampers to circulate the outside air and increase the evaporation load. At the same time, the evaporator fan motor is maximized to increase the evaporation load. Conversely, close the front and rear doors to lower the evaporative load. When the middle knob is opened and the evaporator fan is operated, cold air circulates only in the chamber, and the refrigeration experiment can be performed. To provide more precise load control, adjust to the rack pinion gear scale shown on the front door damper. Let's proceed with the experiment. Please check the banana jack and DA100 connection of the standard refrigeration system. Check the low and high pressure gauge to check the amount of refrigerant charge. After confirm that pH diagram is constructed correctly in the software, the experiment is carried out in earnest. First, set the evaporation temperature, the temperature at the evaporator inlet, to -15 degrees Celsius. Adjust the opening of the expansion valve to regulate the amount of refrigeration circulation. When the manual expansion valve is turned counterclockwise, the amount of refrigerant circulation increases as the opening degree is opened. So, temperature and pressure will be low. Conversely, when turned clockwise, the amount of refrigerant circulation decreases as the opening degree is closed. In the above video, the temperature needs to be lower than the current temperature, so turn it counterclockwise to lower the temperature. Check the temperature of the evaporator inlet position while viewing the temperature table on the temperature display and software attached to the control panel. When the temperature of the evaporator inlet reaches -15 degrees Celsius, the damper opening degree of the acrylic chamber is controlled, and the evaporation load change is given. Open both the front and rear doors to maximize the evaporation load and check the degree of superheat. Check the temperature at the evaporator outlet and the temperature at the compressor inlet, and calculate the superheat. At the same time, the supercooling degree is calculated by checking the temperature of the condenser outlet and the expansion valve inlet. If the temperature and pressure are kept constant in the above state without further temperature change, this is the steady-state operation under the above conditions and confirms the saved data. When you enter the KTENG setup folder on the C drive, a folder named Save Data is created. Measurement data in this folder and saved as an Excel file. Saved data is recorded every second. Check the storage time and find the data in the normal state. Using the above data, Draw a pH graph in the CoolPak program. First, confirm the position of the measured temperature. Next, check the evaporation temperature -15 degrees Celsius data set in the experiment. And check the condensation temperature. The condensation temperature is about 37 degrees Celsius. To calculate the superheat, check the evaporator outlet temperature and the compressor inlet temperature. The evaporator outlet temperature averages about 2 degrees Celsius and the compressor inlet temperature averages 19.8 degrees Celsius. Therefore, the superheat is 17 Kelvin. Next, to calculate the subcooling, check the temperature of the expansion valve inlet and the temperature of the condenser outlet. The temperature difference is 15 Kelvin, which is the subcooling. Using the above measured values and calculated subcooling and superheat degree, we will draw the pH diagram with CoolPak program. Click the cycle input icon and enter the measured value. Enter an evaporation temperature of -15 degrees Celsius as confirmed in the Excel file. Then enter the condensation temperature of 37 degrees Celsius. Enter the calculated superheat of 17.7 Kelvin and the subcooling of 15 Kelvin. When you click Draw Cycle, the pH diagram is plotted. In actual experiments, the pressure drop is caused by the length of the pipe and various factors. Let's check the Excel data. First, let's look at the differential condenser value. This value is the pressure drop from the condenser inlet pressure to the expansion inlet. In this experiment, a pressure drop of about 0.2 bar occurred. Let's look at the differential suction line value. This value is the pressure difference between the evaporator outlet and the compressor inlet. It is calculated here to be about 0.2 bar. Let's draw the pH diagram using these values. Enter the evaporation temperature, condensation temperature, superheat, subcooling degree equally, and input the calculated differential condenser and differential suction line value. You can see a noticeable difference on the graph, and you can see the pressure drop.